So now let's go over section 7.2. So we're going to be covering the production in the short run. And we'll go over what the short run is in a second. So we already know the factors of production, right? We have land, labor, capital, technology, entrepreneurship, right? Remember, capital is going to be things like machines. Okay. So, all these things are inputs that we use to outputs, right? So let's talk about something like easy, like a pizza. What do you need to make a pizza? Well, we have the dough, we have sauce, we have cheese, we have toppings, we have plates, we have all these things in order to just do one pizza, right? And not only that, we also need the person to make it, we also need the oven, right? We need all these different things in order to make one pizza. So we're using all these, and all these are not free. Right, so we do have to pay money for these things. So another thing we have to consider is not one person can make a million pizzas, right? So we have to also consider how many people do we need to hire. So let's go into that. That's why we have the production function. The production function is a mathematical equation that's going to tell you how much output a firm can produce when given a number of inputs. Basically what's happening here is, like, if I gave you 5 employees, 3 ovens, and 1 entrepreneur, and you have 1 kitchen to do all of your work, how many pizzas can y'all make with all of those inputs? Right? So that's what the production function is like you take all the inputs that you have and you're like, okay, well, how much output can you make? Okay, so that's what the production function is. It's just telling you, based off of the different factors that you have, 3 employees, 3 ovens, 1 entrepreneur, 1 kitchen, how many pizzas can you make? So that's the production function. So in that, we do have 2 inputs. There's going to be fixed inputs and variable inputs. Fixed inputs are going to be the things that can't easily be changed or in a short period of time. So, like, for instance, right, if you had a kitchen, okay, if you wanted to change your kitchen, it's going to take a long time in order to do. So you're probably not going to consider kitchen a variable input, because a variable input is going to be where the factors of production can easily increase or decrease in a short period of time. A fixed input would be something like the kitchen. It might be a building. It might be your lease on a building, right? Those things are not going to be changing very fast, right? It's going to take a year, it's going to take months in order for the fixed inputs to change. So when we're talking about something like the pizza example, right? We need a building, so that's fixed. We might need an oven. That's going to be fixed too, because you can't really change the oven. Like, you can't add something to it. You buy it as is. So that's going to be a fixed input as well. Those fixed inputs, most of the time, are going to be capital, right? Because, like, once you buy a machine, that's basically it, right? You could add to it, right? But, kind of, you buy a machine, you're going to use it first, you're going to use it for a while before you decide to add on to it. So again, it's kind of like a fixed input, where it's just like you have it as is right now, it's going to stay that way for a bit. And so that's why we use K for fixed inputs, K for capital. If you did not know, K stands for capital in economics. And then we're going to have variable inputs. And the variable inputs are the things that you can easily change, right? So if, like, I wanted to lower my cost on a pizza, right, I could just take off some of the pepperonis. Okay? If I wanted to increase my cost, I could put more pepperonis on. If I wanted to decrease my cost, I could hire less people. If I wanted to increase my cost, I could have 5 people working on 1 pizza. Okay, so we really could do that. That's a variable input. So that's why we say L is going to be a variable input. L for labor. That one does make sense. Okay, so that's the thing about the variable and the fixed inputs. Fixed inputs are going to not be changing over time or for a short period of time. Variable could change instantly. So for this class, we don't have this complicated production function up here. We have a much simpler production function. Okay, all we're going to look at is your labor and your capital. That's all we're doing. So basically, if you had five people and 3 ovens, right? That's what you have. How much output can you make? That's what the production function is. Okay? So I mentioned that we're going to be covering the short run. So in the short run, here's how it goes. There's going to be a period of time during which some factors of production are fixed. So when we talked about the oven, when we talked about the building or the kitchen, right, or the lease for 12 months, those are going to be fixed because they're not changing over the short period of time. So because it is limited to, because you're limited to using your current building, right, you can't easily change the size of the building, right? You would have to physically move to a new building, and that requires a new lease. Okay, so when you're in the short run, at least one input is fixed. So basically, you start a business, right? And you have employees, you have ingredients, maybe you have an oven that you're renting. So maybe you're changing that in and out all the time for whatever reason, okay? But you're having a lot of variable inputs, labor, ingredients, right? But you still have that one building that you had the lease for. So you're kind of stuck there for 12 months. So that means you're in the short run. If you have at least one input that is fixed, right? You could be all variable, but if you have a lease, for example, that's fixed. If you have all these variable inputs, but you have one machine that is not changing, right? That is a fixed input. So therefore, you are in the short run. Short run. Nothing wrong with the short run, right? Because basically, you're stuck in this building. You just have to make decisions based off of where you're at right now. Okay. Now, the long run, that is where all inputs are variable. Meaning, if you are looking next year or 5 years from now, right? You don't need to be in this building. You can be in a bigger one. You can be in a smaller one. You can have 5 ovens. You can have no ovens. You can have more employees, less employees. Everything can change in the long run, right? You're not stuck. You're not signing a lease 5 years from now, right? You're signing the lease today, which is in the short run. But in 5 years from now, right, you could think about signing over here, or you could think about signing over there. It's variable. You can change in the long run. So in the long run, everything is variable. Absolutely everything can change. Okay? And that can happen once the lease is over. Once the lease is over here, you can pick a smaller or bigger place. It's like looking into the future and being able to make changes without something being fixed. Like you can have the idea today to hire 10 employees, and then you change your mind the next day. Nothing changed, right? Like you're not fixed on it. Everything is variable in the long run. Okay? Very, very important. What's the biggest difference there between the short run and the long run? The long run, you have no fixed inputs. Everything is variable. Short run, at least one is fixed. That's the big difference. And so now that we established what is the short run, let's take a look at basically you have signed this lease or you have this one oven. Let's make the best of it. Okay, so in the short run, let's see what happens here. We can use the production function to figure out the output that we are getting out of our labor and capital. Basically, if we had one employee, how much stuff are they making? If we had 2 employees, how much stuff are they making? Okay. So output is just the total product that a firm or worker makes. That's what output is. It's just like the total product that you can make. So let's assume capital, or K, right, is fixed in the short run. So looking at this picture here, right, we only have that one saw blade. So one piece of capital, but we do have a variable labor. So labor can change. So labor can change. You can have 1, 2, 3, 4, or 5 lumberjacks. So what are we noticing here is that when you hire one employee, one lumberjack, all right, you're making 4 trees. You're chopping down 4 trees with one lumberjack. When you have 2, you're now jumping up to 10. All right. When you hire 3, you're at 12, 4, 13, and then 5 is 13 as well. So if you had 5 people, if you had 5 lumberjacks, right, that is 13 people. 13 trees that you're cutting down. All right. So that's what this production function is saying. It is like if you had one saw blade and 5 employees, that's your inputs. You're making 13 trees. That's your output. Okay. Now, what's the issue here? Look at that third guy that's sitting there, right? I mean, he could be doing something, right? But right now he's doing nothing. So we're getting to this point where, yeah, we are making more stuff, right? But there is an issue here, right? The issue is the marginal product. The marginal product is going to be, what is that next person doing? Like, if you hire somebody, what is the extra thing that they're making? So if we had one employee, right, one lumberjack, then we have 4. Imagine trying to do everything yourself, right? You're not going to be able to make many, chop down many trees because you're trying to, use the saw all by yourself. So it's going to take you all day in order to do it. But if you had 2 people, right, just like we saw in the picture where there were, one on each side, we can now increase the amount of production we're doing. And we can actually get it up to 10. So we went from 4 to 10. So because we hired the second person, we can now make 6 more trees. That's how the marginal product works, is like, what is that next person doing? You used to do 4, but now we are doing 10. So because we hired the second person, that's a marginal product of 6. When we hire the third person, right, we go from 10 to 12. So that's an increase of 2. We go from 10 to 12, it's an increase of 2. All we did there was 12 minus 10, and that equals 2. And that's how we find the marginal product. Okay? Well, so what happened here? We went 4, 6, 2. Right? We were going 4, 6, 2. All right, so what happened there? Well, what happened there is what we call the law of diminishing marginal productivity. So we had one person that was trying to do everything, and it was like really stressful. Then we had 2 people, and they were able to basically get on one side and just start sawing away, and they were able to make 10. And then we had the third person, and well, we only have one saw. So this third person, right, they got to kind of figure out what they need to do. Right, the third one could help out with smaller tasks, right? They could basically bring the other 2 guys water, they could bring them oil for the saw blade, they could do the little tasks to where the other 2 guys aren't wasting their time doing something else. So this could help out actually. But again, it's not as much, this is not increasing the total product as much as the 2 workers did, right? Because 2 workers, right, we worked 4, 6, right, we were on the up on increasing. But then we got to a point where, that third person wasn't able to do much. So we had diminishing marginal productivity. We went 4, 6, 2, right? So if this were 8, if this was 4, 6, 8, is that diminishing? No, right? Because we're going 4, 6, 8, 2, right? So when it goes down, that is when it's diminishing. Okay, so imagine going up, down, that is where it's diminishing. Okay, so the law of diminishing marginal productivity starts after the second worker. So law of diminishing marginal productivity starts after second worker. Or it started with hiring the third worker. Okay, so let's do another example here because I really want you to understand what the marginal product is doing. All right, so if we had 0 labor, then that's 0 total product. But if we had 1 labor, right, we're now making 20. So the marginal productivity, right? So going where you started, where you ended. You started at 0, you're ending at 20, so the marginal is 20. All we did there was 20 minus 0. For the next one, you're going to 50, right? Look at where you started, look at where you ended. Because you hired the second person, so you were at 1, but because you hired the second one, right, you're now doing 50. So that's an increase of 30, right? Because you went from 20 to 50. 20 to 50, that's an increase of 30. What about the next one? We go from 50 to 90, okay? Is the marginal productivity 90? No. Is the marginal productivity 50? No. Is it 160? No. Remember, marginal productivity. Marginal meaning the next. So the next product that we're doing, right? Because we hired the third worker, what's that extra that we're making? Well, we were at 50, now we're at 90, so the extra is 40. All right, and then finishing out the rest here, that should be 5, and that should be 1. And that's how we find marginal product. Now, question then becomes, when does the law of diminishing marginal productivity start? Does it start with the second one? Does it start with the third one? Fourth, fifth, or sixth? So, law of diminishing marginal productivity talks about is whenever you start to decrease your marginal productivity. Okay, so we're going 20, 30, 40, 5. All right, so we're going up, 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 down. As soon as you go down, that's when it starts. So law of diminishing marginal productivity starts after the third worker. After the third worker, that's when we have diminishing marginal productivity. So the main thing is figuring out how marginal product works. All it is going from step to step. What is that increase or decrease? That's marginal product. And this is what it's going to look like on a graph. So, if we were to graph the lumberjack question from earlier, we can see how the total product is increasing, right? But it's not increasing like just keeps going up, right? It's increasing, all of a sudden it starts to level off here. So that's where we're having that diminishing marginal productivity, because like you are increasing, but at a slower rate, right? Because it's going up, but then it starts to level off here. And we can actually see that when we talk about the marginal product, because it is increasing, right? But then all of a sudden it starts to go down, right? And when it starts to go down, that's when we're starting to level off. And so whenever the marginal product is positive, like in this graph right here, the marginal product where I have green circled, whenever the marginal product is positive, that does mean you are making more, right? You are increasing the total, all right? Because that second person or that third person, right? They did have a marginal product of 2. So they were helping you make more things. They were able to help you make 2 more. That is a positive marginal product, which did add to the total. So anytime the marginal product is positive, this does mean the total product is increasing. When the marginal product is decreasing, right, that is where, it's going downwards. So if you're reading left to right, when you hire the first worker, you're at 4. When you hire the second one, it's increasing, right? So it's going up. But then when you hire the third worker, fourth, and fifth, it starts to go down. So when marginal product is decreasing, that is where total product is increasing, but at a decreasing rate. Because it's decreasing, right? The marginal product is going down. So, and it's positive. So total product is going up because it's positive. However, right, it is going down. So it's going down, so therefore the total product is increasing at a decreasing rate. And that's where we see the leveling off of the total product, right? It's going up and then leveling off. So that is the short run production graphs. These are general cases. So basically, if we hire people, they're doing really well, so they're working really well, we're able to increase our productivity, fantastic. And then all of a sudden we get too many people and then we have to level off. I like to think of this one as like if one person's in the kitchen, right? We have the person trying to make the pizzas. We're trying to, get them in the oven. We're trying to take them out of the oven. We're trying to work the register. We have so many things for one person. But, if we have two people, right, we can have one person on the register, one person on the ovens, right? And then we can basically increase our margin of productivity. But then we start to add 5, 6, 10 employees in that same kitchen. All of a sudden, it's like you're working like this and you're trying to, do work, but you can't because there's so many people around. So that's where the marginal productivity starts to go down because you have so many people in the kitchen. It's kind of hard to work around them. Okay. So that is what we're looking for on the short run production function. If I were to ask you to draw these graphs, this is what I'm looking for. I'm looking for the total to be increasing, right, and then leveling off. So it goes up and then levels off. And then for the marginal product, right, it should look like this. It should go up and down. That's all it should be, okay? So I'll draw them right now for you. Okay, total should go like that, and then the marginal should go like that. Okay? That's the way it should be. Okay. Now, in the next video, we'll go over section 7.3, which is cost in the short run. I'll see you there. Bye.